Hi Year 10, here's the second video to address the second set of learning intentions for your electromagnetism unit during semester 2. So the things we're going to look at today all are about using your right hand to work out some problems that we'll pose to you. Let's just have a look at these. So I can apply the right hand grip rule to indicate or to draw the magnetic field around a current carrying wire. So what that means is if a wire is carrying a current in a particular direction, we actually have a magnetic field forming around that wire. And magnetic fields, as you know, have a direction on them, and you're asked to label that direction using arrows. When it's a bar magnet, you have a north and a south end, and the magnetic field goes from the north to the south. In a current carrying wire, we'll have a circular magnetic field travelling all the way around that wire, but it will still have a direction on there. So what you're asked to do using the first right hand rule is to determine that direction. Okay, so I'm just going to whiz forwards to the page that shows you this. So this is in the PowerPoint that you will find on LMS. So if the wire is carrying the current in an upwards direction, you want to have your thumb representing the direction of that current going upwards. And in that case, this first right hand rule, which we call the right hand grip rule, shows you that the direction of your fingers represents the direction of that magnetic field. So in this situation, the field is going round and following my fingers like that. So you'll be asked to represent that potentially in a test question. And one other thing that you need to know is that how do we represent the direction of the wire on a page that's two-dimensional? What we'll show you is that the wire is coming out of the page towards you if there's a circle with a ring around it. And if the wire is going down and away from you, or the current is going down and away from you, we'll represent that with a circle and a cross through it, just like that. Okay, so that's a really useful thing for you to remember. So the first right hand grip rule, or the first right hand rule, tells you how to work out the direction of the magnetic field around a wire that's carrying a current. Okay. The next rule that you need to learn and you need to understand is the solenoid rule. Again, you'll just use your right hand. So remember not to use your left hand in any of these questions or scenarios. Some videos that you may find on YouTube might be American videos that do use the left hand, but we don't use those. Okay, so just stick with the right. Now, a solenoid is a coil of wire, and you've built a solenoid when you did your electromagnetic practical, and you wound a wire carrying a current around a soft iron core or a long nail. The solenoid rule helps you to determine which end of that electromagnet is north and which is south by working out what direction the current is travelling in, and again using your right hand. Okay, so first thing you need to recall from year 9 is that when you're looking at a cell or a battery, which end is negative, which end is positive, and what is the direction of that conventional current? So here we have a single cell, and we've got the small line there which represents the negative side, the negative terminal of that battery, or the cell, and here we have the longer line representing the positive. So what we know is that conventional current moves away from the positive and towards the negative. So the first thing you're asked to do or I recommend that you do when you're faced with this kind of question, is to draw arrows indicating the direction of the conventional current. Now there's tiny arrows already on here. And start with the straight lines, showing that the conventional current is moving this way, up the wire, and then pay attention to how the wire is coiled. So it's coming over the front, so draw a downwards arrow there. It goes up the back and over the front again, so again another downwards arrow, and around and around and around and down here and along towards the negative terminal. So what you've established there is the direction of the conventional current. Then this is where your right hand comes in. So your fingers represent that direction of that current. So wrap your fingers in the direction of the current carrying wire. So if it's wrapping that way, wrap your fingers towards yourself, and then the thumb will represent the north. So last year I drew a large uppercase N on everybody's thumb in Sharpie, and that's a really good thing. You're very welcome to take that into your test. And that means that if you can identify the direction of the current and you can make your fingers represent that direction, and you only use your right hand, you will always know which direction is north on that magnet or which pole is north on the magnet. And therefore you can apply this solenoid right hand rule and get all of your answers correct. This is another representation of the same thing. So here we've got, if you imagine, we've got a cell and we've got the positive terminal here, and the current is going in this direction and it's wrapping around. So you can see how they've labelled the direction of the current and going in towards the negative. The fingers are wrapped around in the same direction as the current, and the thumb is pointing towards north. So that's how you use that rule there. And there's another one. Okay. And that takes us to the final learning intention for this final physics unit for year 10. We'll move on to that in the next video. So have a try of the questions that we've set you in the workbook and see if you can apply the right hand rules that we've taught you so far.